Welcome back. Previously, we looked at substitution reactions involving SN2 and SN1, and we're going to continue our discussion along those veins, but this time we're going to look at elimination reactions, E2 and E1. And as with SN2 and SN1, E2 and E1, E2 shares a lot of similarities with SN2, and E1 shares a lot of similarities with SN1. The only major difference between substitution and elimination is elimination reactions result in the formation of a double bond, whereas substitution reactions are straightforward. You just substitute one with another. Okay, so pretty much this screen would look almost similar to what we looked at. Typically negatively charged bases or strong bases, and then among them there's also a bulky strong basis, which I have highlighted in the red boxes. And as I've said before, CH3O minus Na or CH3O minus are essentially the same thing, but from a test perspective, some people include the sodium, some people don't. But you do need to know that there's a strong base, and then there's a bulky strong base, and the neutral bases, okay, which are usually very weak. Okay, and as with SN2 and SN1, in E2 and E1, 2 stands for bimolecular, 1 stands for unimolecular, and you also have an option for protic or non-protic or aprotic solvents. Protic typically means more polar, and aprotic typically means non-polar. And here's the sequence of the leaving group that we've looked at. So the group on the far right side, this has a higher tendency to leave. This right here has a higher tendency to leave, and this has a lower tendency to leave. Or even here, you know, a group is leaving, it's just not getting substituted. Once it leaves a double bond behind it. Okay, but the group still has to leave. Okay, so that's even common between SN2, SN1, and E1, E2. All right, so E2, I'm just going to run through this really quick. As with SN2, with E2, it's a bimolecular, means it depends on the concentration of both the substrate and the nucleophile. And E2 reactions are considered, that is, the reaction happens in a single step with no intermediate formation. E2 reactions are typically carried out with strong and bulky bases. So it's not just strong base, it has to be strong and bulky. Okay, elimination reactions typically involves the use of heat, and even if heat is not present, the moment you see a strong and a bulky base indicates that you do have an elimination reaction. And E2 substrate reactivity, methyl groups have the higher, you know, the substrate is where the leaving group is, right? And if the carbon containing the leaving group is methyl or primary, have a higher tendency towards elimination versus a tertiary. And as with elimination reactions, generally you have to use the Zaitsev rule. And what does it say? The more centered the double bond is, more stable the molecule is. Okay, so here's something I wanted to do even when we did SN2, SN1, but for some reason I did not take the time just to do this. So let's do a quick practice before we actually do elimination. I'm asking which of the following substrate contains the best leaving group. Now, you do have to memorize the leaving group sequence to a certain extent, but generally speaking, the bigger the group, generally it's a better leaving group. So out of all of this, this is the poor leaving group. This is a second better poor leaving group. This is slightly better, but this is the best because this is the biggest. So this will be the better. This is a substrate with the best leaving group. Okay, and then which of the following substrate has the highest reactivity towards elimination? Like I said, if your leaving group is attached to a carbon that's either methyl or primary, typically has the highest tendency. And this is a tertiary. This is a tertiary. This is a secondary, this is a tertiary, and this is a primary. So these are the carbons where the leaving groups are attached. So that means elimination reactions are generally favored by methyl or primary substrates. So this would be the substrate containing the leaving group that has the highest reactivity towards elimination, E2 reaction. Now actually let's look at the E2 reaction. Now if you see right away, I have a substrate containing a primary carbon to which the leaving group is attached. This is a strong and a bulky base, and we have heat, which is an indication that an elimination is happening. And this is a protic solvent. With elimination reaction, it really, E2, it really doesn't matter whether it's protic or aprotic. You can do it with both, but generally we use protic solvent. So what's really happening here is the leaving, the nucleophile, I'm just going to redraw this, okay? This is the carbon containing the Br, but there must be a carbon with an adjacent carbon containing a hydrogen. So the nucleophile comes in, grabs this hydrogen, okay? And in the process, the bond that is attaching the carbon and the hydrogen comes back into the chain, and in the process, it creates a double bond. Keep in mind, a bond is a bond, doesn't matter where it is. So, and in the process, the Br comes out, okay? So that means this is what you'll be end up with, okay? Basically, you're just adding a double bond between the carbon containing the leaving group and the carbon adjacent to it containing the hydrogen. You cannot remove the hydrogen from the carbon containing the leaving group. Yes, this carbon does have two hydrogens, but you cannot remove that. It must be removed from, this is called the beta carbon, which is actually containing the leaving group. This is called the alpha carbon, which contains the adjacent hydrogen. So the nucleophile attacks the hydrogen on the adjacent carbon, and in the process, the double bond comes in and then creates a double bond. All right, so how do we write the rate of the reaction? Well, the rate of the reaction is K times substrate. You can just simply draw it out, and then that, or you can simply count everything. So it'll be 1, 2, 3, 4 carbons, 3, 6, 7, 9 Br, and then you can write this out. So it's bimolecular because it depends on the concentration of. Now, I do want to mention this nucleophile, the strong bulky base, it's also written this way, T-butyl O minus Na plus. You might see this occasionally on a professional exam. All right, so that's how you do an E2 elimination. And I want you to practice this and answer these questions as part of your My Thoughts, where this carbon is interesting. When the carbon is primary, you only have one product. When the carbon is secondary, you have two products, because you can remove this hydrogen. This is alpha as well, because this is adjacent to the carbon containing leaving group. This is alpha as well, because this contains 3 hydrogens in the methyl. You can remove one of them, okay? You can remove one of them. You cannot remove all 3. So you can either have a double bond here or here. So you have 2 separate products, and I want you to draw them out and then determine which one is the stable product. And I'll see you back with E1 elimination.